Welcome to this session of Xcode in the Playground. Today we're going to be looking at the decision structure. Our learning objectives are going to be, well, how does the decision structure work? We're going to look at Boolean condition. We're going to look at the if-then, the if-then-else, the else-if nested structures, and also look at the switch structure, which is sometimes called a case structure in other programming languages. The decision process is fundamental to computers. All computers have to make a decision. So let's have a look at how this structure works by opening up our Xcode in its playground and starting a new project in there. Okay, now that we've got a new playground, the first thing I'm going to do is delete the current existing information in the playground and put in a developer comment. It's a very good developer principle to use comments throughout your code, and always start with my name as the developer at the top of my code. So we're going to be looking at the if-then-else statement. It uses a structure that enables a condition. So we use what's known as an if and then a condition. Now that condition can only result in a true or a false response. And that's why it's known as a Boolean condition. Depending if it's true, if the condition results true, we do the then part. But if the condition results false, we do the else part. Now the condition can be a whole lot of different things. It could be if grade is greater than 50. And if this is true, then you passed. But if it's not true, it could be, sorry, you need to study harder. So depending on what the condition is, depends if we do the then part for true or the else part for false. So let's start by looking at this in practice by starting with the if-then statement. So let's have a look at syntax. So let's declare some information. Let's go var test result equals 60. And then we can use if test result is greater than or equal to 50. So if that condition results true, we can then go print you have passed the test. So let's run this program. Now you can see in our output at the bottom that we have passed the test. If we look in the inspector window on the right, you can see that the test result was 60. Is 60 greater than equal to 50? The answer to that is true. Because it is true, it does the then part. The then part is defined by these two braces. So we've got an open brace and a closed brace. This is different to an open bracket and a closed bracket. So the if-then-else statement uses braces to define the begin and the end of the then part, and it also will define the begin and the end of the else block. So let's have a look if we don't pass. So rather than using the if-then condition, let's look at the if-then-else. Remembering that this is the false part. To do the else clause, we just need to put in else and then open the brace again and close the brace. Now you notice that else sits on its own line. This helps you distinguish between the then begin and the else begin. If we have more parts to print, you'll pass the test and print well done. You can see that all the then parts are lining up in a straight line. It's important that you stub your code out consistently. Stubbing is the spaces from the start of the line to the indent. So with the else statement, we're also going to stub it the same amount as the then part, and we can use another print statement. I might need to study more. So if the result of the condition here is false, then it will run the else part. At the moment, 60 is greater than 50. But what happens if I've got 30 for the test? Say 30%. Let's have a look when we run the program now. You can see that the program in the inspector window has passed out, I might need to study more. And you can also see that in the bottom output as well. So if the condition is true, it does the then part. If the condition is false, it does the else part. So let's have a quick look at the if then else if we're checking a password. So I need to declare var password. And that's going to be a type string. And that could be equal to, say, lmarsden.com. And then we can actually have the attempt. So let's go let attempt, which is also a type string. Need to use capital S. And we could actually deliberately get that wrong. So we can see they're not correct. So what we might want to do is check to see what the password is against the user's attempt. So we then, to check to see if they're the same, we've got to use the if statement. So the if is a comparison. Is this the same as this? We do use all the Boolean operators. So less than, greater than, equal to, not equal to, greater than, equal to, less than, and equal to. You can have a look on my YouTube channel for the tutorial on that. So when we set up the condition, it is a Boolean condition. It must result yes or no. There is no yeah, nah, or kind of. So let's check this. Let's see if the password equals the attempt. Now you notice that the single equal sign is an assignment. So put this into this. And the double equal sign is a comparison. Is this the same as this? For the then part, we can then open a brace and we could print correct password. But if they get it wrong, print wrong password. Now we see that they're both not the same, so we should get wrong password as the output, which is correct, and you can see in the output window. If we make them the same and run the program, we now should see correct password. This is the most common structure for decision that you'll use. Now we can also nest our constructs. So what if we want to work out if someone is a child or a teenager or an adult? Because there are three possibilities, we need to do what's called a nested if-then-else statement. Now what a nested if-then-else statement is an if-then-else statement inside of an if-then-else statement. So if I want to work out if they're a child, a teenager, or adult, there are three conditions here. So we need to run the first condition, and then we can need to see, well, if that is true, we could then print something out. But if it's not true, then we could do another check. So else if, and then do another condition. So depending if that is true, we could then have a then part. And if that's not true, we could have an else part. So let's have a look at creating this program to see if you're a child, teenager, or adult. So let's declare a new variable. So let age equal 18. Okay. So we know that 18 should be an adult. So we can use a decision like if age is greater than or equal to 18. So therefore, anyone that is 18 or above. So if you're 21, that's greater than 18, so you're an adult. If you're 18 in Australia, you're considered an adult, which means you're equal to 18, so this result would end up true. If you are 13 and a teenager, 13 is not greater than or equal to 18, and therefore would result of false. So we can then do the true part. So if this condition is true, that you're 18 or above, so if you're 99 years old, it'll make you an adult, we can go print, you are an adult. So let's run the program now to see that this is working. It's a good idea to test your code as you go. So you can see that you are 18, you are an adult. So this is true at the moment. So, but if I'm not that, and I use the else clause, I then need to work out, well, am I a teenager or a child? Now a teenager is someone who is, say, 13. So we can actually use what's called an else if statement. So rather than have the brace here, we can go else if age is greater than equal to 13. Then do something. What do we want to do if they're greater than equal to 13? We want to print that you are a teenager. Now the reason why this would work is because 13, is this greater than or equal to 18? No, it's not. So the first condition here is false. So it does the else part. The else part has what's called an ElIf, else if statement. So it runs another condition, which is, so this is false, then it does another check of this condition. If age is greater than or equal to 13, in this case it's equal to, so it's true, so it does the then part of this. So logically, it sort of states that if you are not greater than or equal to 18, and if you're not greater than or equal to 13, then obviously then you're a child. So the else part here, which is the else part of the second if statement, and what I'm going to do is indent that in. So this if statement here, or this else here, belongs to this if statement. And this print belongs to this if statement. That if you are not greater than or equal to 13 and therefore say 10, then it should print you are a child. So let's have a look at this program running. You can see that you're a teenager. So let's now set the age to 10 and run the program now. You are a child. If we logically step through, is 10 greater than or equal to 18? No, so it's false, so we go to the else part. Now if 10 is greater than or equal to 13? No, so that's false, so we do the else part. The else part says print you're a child, and that's what the program has done. So this is using a nested if then else statement and looking at what's called an else if statement, or an ElIf in other languages. Because there are if statements inside of other if statements, it's also known as a nested construct. So the constructor if then else is inside another if then else, and therefore they're nested inside each other. You can have decisions coming off the else part. You can also have the decisions coming off the then part as well. So else if age is greater than or equal to 13, true, you could then have another decision in here and say, if eye color equals blue, then do something. So this is an if then else statement, or an if statement off the true branch. So the then and then having another if statement off here, or we can have an else and have an if statement coming off here. So it's quite a versatile structure to help you resolve complex decision making. There is one more tool that we can use in our decision structures, and that's known as a switch statement. Now a switch statement helps us resolve very long and complex if then else statements. It flattens out the structure. So the switch structure, some people will know it as a case statement. So in Visual Basic, you'll see it as a case this. A lot of language use switch now. It asks you to switch the variable. So the variable is important here. So it says, well, we're going to switch the variable, and then we're going to run some structures to test it. So what we're going to do is we're going to go, well, case it is an A. Then we can do something. And then we go, well, what happens if it's a B? We could do something. And that something could be a whole series of different code lines. But at the end of the list, we can also have what's called a default. This is like the else clause. What happens is none of these cases are true. So if no case is true, it does the default. So let's have a look at this in action. Let's set a character. And this character is going to be of type char, which is a character. And we're going to let that equal, say, Z. Now we can begin the switch structure. We can go, well, switch some character. And what do we want to switch it and test it with? Once we've opened the brace, we can go, well, case some character is an A. Then we could go print first letter of the alphabet. Now, if it's not an A, we can then use the default. And we can say, well, if it's none of these, we could then go print some other character. So let's have a look at this program running now. You notice the result is some other character. Because it's done the test of case A, it's not character, some characters are currently Z, therefore it does the Z. We could have a whole series of different other ones. We can copy this line and say, well, case it is a B. And we'll indent to keep our structure nice, and I'll just try to flatten it out nicely. So case it is a B. It can be the second letter of the alphabet. So let's change our character to B. When we run our program now, you can see that it's the second letter of the alphabet. If we want to go all the way through to Z, we could then go case Z, and this could be the last letter. When we run our program now, you'll see that it's picked up the last letter. If we change it back to an A and run the program, it'd be the first letter. So it's going through this list and finding out what the letter is. It also works for capitals. So if I go case, it's a capital Z. And change the input to a capital Z and run the program, you can see it's a capital Z. So it does pick up the different types of char. It also works case it as a number. So you can change the condition of the switch statement to check against the contents of the variable. And if it is none of those and we change it to a symbol, it will go some other character when we run the program. Now, if we were using this for a dice roll, we could actually change this to dice, and we'll change this to an integer, and we'll make, say, the number 1, and then we can change the variable to dice, so it's checking against that variable. And in case it is a 1, a 2, a 3, a 4, etc. We can change the contents here to you rolled a 1, and we can change the other ones as well. And when we run our program now, you can see you've rolled a 1. If the variable then becomes a 4, you can see you've rolled a 4. We can also add variables to this as well. So we can have multiple lines. So I can go var 1 count and let that equal 0. And then in here, I can actually go 1 count plus equals 1. And when the program finishes, I could actually go print 1 count. So if I change this to a 1, run the program, you can see that you've rolled a 1 and I've outputted the total count of 1. So in this tutorial, we've looked at the decision structure, Boolean conditions, if then else, the else if nested structures, and also the switch structures. So I hope you found this tutorial useful. If you did, give it a like, subscribe to my YouTube channel. Also have a look around my YouTube channel for other useful programming tutorials. And I look forward to seeing you in the next session of Xcode in the Playground.